90 project, our wireless charging car. Here we have a supercapacitor vehicle, model car, that we rigged up to be able to charge wirelessly using resonant inductive coupling.
These are the pads that we use that are wirelessly coupled. They are coupled through inductance. So they resonate at a frequency of 5.7 megahertz. One of these pads will be attached on the side of this car, like so, and we'll be able to just drive on top of the other pad, which will be on a standalone transmit side. And the receive side will take that, rectify the alternating current signal, and then allowing our supercapacitors to charge with DC. And we would all use a Raspberry Pi to generate that signal.
Yeah, so just like you said, some of the important parts of our project are the Raspberry Pi and these little op amps right here. The Raspberry Pi creates our 5.7 megahertz signal, and then our op amp is able to ramp that up in current so we can get a faster charging car.
The issues we ran into were these coils resonate at 5.7 megahertz. It's a really high frequency to be able to generate using the Raspberry Pi. We weren't able to achieve that. Also, the op amps are quite expensive, and they're pretty tricky to work with.
So the op amps, the OPA 2614 is what we chose. It's a high-speed, high-output op amp. It says it's rated to output at about 300 milliamps per channel. There's 2 channels per channel. We got 3 of them each. What we saw when we tried testing them as an amplifying circuit, just in an inverting op amp situation, that it was actually summing a 20 megahertz default signal for some reason, and summing it with whatever our input signal was. And the higher the frequency we got, the less we saw of that 20 megahertz, the more we saw. So a lot of our testing was hard to do because we were a little unsure about some of the equipment, but also getting 5.7 megahertz to test with a clean sine wave was a little challenging for us as well. But we ended up doing some stuff in the RF lab as well. That was one of our big challenges, was getting that 5.7 megahertz. So if you can figure out how to do that in an efficient way, more power to you. This will probably become more reasonable project. Also,
No, I was just going to say, at the end of it, we eventually just ran out of time and we ran out of money. If we had more time and more money, we would have been able to invest more into, probably not an op amp, probably would have gone for a transistor that was able to output more power. These supercapacitors can take up to about 40 amps each. So we really wanted them to charge in under a minute. In order to do that, we needed at least 3 amps. So that was one of the constraints that we were working with.
some ideas to think about when building upon this in the future. Just really look into maybe finding a smaller way, or a lower frequency, I should say, where you can still transmit high power, or find a way to generate that 5.7 megahertz signal. That's what we have.
So it was a pretty cool project. We wish you the best of luck and hope you can continue on it.